Science, at its core, is meant to be a continuous journey of curiosity, openness, and the humble acknowledgement that no matter how much we think we know, there is always far more left to discover. This is the point I emphasized during my interview with Peter Doocy on the Sunday Briefing on Fox News. The essence of scientific progress relies not on the arrogance of assuming our expertise is complete, but on the willingness to revisit old assumptions, question familiar frameworks, and incorporate new evidence, even when it challenges long-standing traditions. Yet, when the Comet 3I/Atlas was discovered on July 1, 2025, many experts in the comet community immediately declared with confidence that it must be another familiar, water-rich comet like the ones humanity has studied countless times within our solar system. They did this almost reflexively, applying the patterns and categories formed over decades of experience. Their reaction reminded me strongly of artificial intelligence systems trained on specific datasets. When you train a model only on examples of one kind, it becomes conditioned to classify everything according to that limited knowledge. For decades, the dataset that comet researchers relied upon involved only icy rocks native to our own solar system. Naturally, when something new appears, they categorize it according to their existing mental framework, even if the new object might fall entirely outside those boundaries. My point is straightforward. Humanity has now launched technological artifacts into space: spacecraft, probes, satellites, and even objects like Elon Musk's Tesla Roadster. This means the cosmic environment now includes not only natural objects, but also artificial ones created by intelligent beings. If scientists want to remain true to the principles of empirical curiosity, they must expand their intellectual training dataset to include the possibility of technological artifacts when studying unusual interstellar objects. The assumption that everything resembling a comet must automatically be a natural icy body is no longer valid in an era where human-made objects have already left Earth orbit, traveled through interplanetary space, and will continue drifting indefinitely. We are no longer passive observers of the cosmic landscape. We are contributors to it. Future scientists examining our solar system from afar would need to distinguish between natural bodies and our technology. Therefore, present-day scientists should grant the same respect to the possibility that interstellar space may contain technologies produced by other civilizations. A vivid example of this principle unfolded earlier in 2025. On January 2nd, the Minor Planet Center, an organization under the International Astronomical Union responsible for cataloging and tracking small near-Earth objects, identified what they believed to be a near-Earth asteroid. Based on initial observations, the object appeared to behave like any other small rock orbiting within Earth's cosmic neighborhood. But only a day later, on January 3rd, officials realized that the trajectory of this so-called asteroid matched an already known object: the Tesla Roadster, launched into space by SpaceX in 2018 as a dummy payload on the inaugural Falcon Heavy rocket. In other words, the Minor Planet Center mistakenly labeled a car, a human-manufactured piece of modern technology, as a natural asteroid simply because it was moving like one and appeared in their detection systems. As soon as the officials recognized their error, they quickly removed the object from the asteroid catalog. They acknowledged that an assumption based on limited data had led them astray. This incident is not trivial. It reveals that even experts, highly trained and deeply knowledgeable, can mistake a technological object for a natural one if they do not anticipate that such objects could exist among the celestial bodies they monitor. If a human-made car orbiting the sun can be misidentified as an asteroid in the 21st century, why should we be so certain that objects entering our solar system from interstellar space must always be natural? And if even we, with our short technological history, have launched objects that will wander through space for millions or even billions of years, is it unreasonable to imagine that other civilizations, if they exist, might have done the same long before us? To insist otherwise is not scientific caution. It is intellectual stubbornness. Elon Musk, for all his ambitions and achievements, is almost certainly not the most advanced spacefaring innovator ever to emerge within the Milky Way galaxy across its 13.8 billion-year history. Our galaxy contains roughly 100 billion stars similar to the Sun. If even a tenth of them host an Earth-sized planet in the habitable zone, that gives us billions of potential environments where intelligent life could theoretically arise. With billions of opportunities and immense stretches of time, it becomes statistically implausible to assume that humanity is the very first or the most advanced civilization to develop technologies capable of exploring or sending objects into interstellar space. The idea that Earth has a monopoly on creativity or engineering is not humility. It is cosmic arrogance. When we roll the dice on such a vast number of Earth-Sun analogs scattered throughout the galaxy, the probability increases dramatically that some civilizations might have emerged earlier than ours, progressed further than us technologically, and perhaps even developed capabilities long beyond our imagination. Most stars in the Milky Way are billions of years older than the Sun. Imagine a civilization that began advancing technologically not a few hundred years ago like humanity, but a few million or a few billion years ago. In that amount of time, even modest spacecraft like our Voyager probes, launched in the 1970s with primitive electronics by modern standards, could drift all the way across the galactic disk. Voyager is currently traveling at about 17 kilometers per second. Over a billion years, an unimaginably vast span of time compared to human history. That speed is enough to traverse the entire galaxy from one side to the other. If our own simplest, earliest interstellar emissaries could achieve this with old technology, then imagine what far older civilizations could accomplish. It therefore becomes entirely plausible, even expected, that interstellar space may contain technological artifacts of non-human origin, objects that left their parent star systems millions or billions of years ago and drifted through the cosmic ocean until reaching the solar system. Some might be intact, others could be debris. Still others could be manufactured in ways that do not resemble our contemporary engineering. Yet if comet experts, astronomers, and planetary scientists examine every new interstellar visitor with only the assumption that it must be natural, they risk overlooking some of the most profound discoveries humanity could ever make. The question I pose is not whether aliens exist, nor whether every interstellar object is artificial. The question is whether the scientific community is willing to broaden its perspective. If researchers limit themselves to a dataset comprising only icy rocks, then they will classify everything according to that limitation. But if they allow for the possibility, however small or large, that some interstellar objects might be technological artifacts, then they open the door to a more honest and comprehensive investigation. Science progresses not by dismissing the unfamiliar, but by interrogating it. It advances when we resist the temptation to force new observations into old categories. Instead, we must be willing to expand the categories themselves. This requires humility, not certainty. Humility to admit that the universe may hold surprises beyond our imagination. Humility to accept that our current knowledge, impressive as it is, remains a tiny fragment of the cosmic picture. Humility to consider that we may encounter objects whose characteristics do not fit neatly into the natural templates we have grown accustomed to. If we cling too tightly to the comfort of expertise, we risk turning science into dogma. The true scientist is not someone who knows the most, but someone who is willing to learn the most, especially when the evidence challenges prior beliefs. Our universe is vast, ancient, and full of phenomena yet to be understood. The least we can do is keep our minds open to the possibilities it presents.